Hello everyone, my name is Anna and I'm on my way to the University of Groningen. I work in the Bioproduct Engineering Research Group and I will show you around today. So let's see what we can discover. What is slowly digestible cornstarch and how does it end up in my drink? What happens to all the leaves that fall into the lake? So many questions. Let's find out. The leaf sinks to the bottom of the lake, where they are degraded by enzymes. Hello, what are you doing here at the bottom of the lake?
Hi. We are carbohydrate active enzymes. We can modify carbohydrates, which are found, for example, in these leaves, but also in other biomass, like wood or grasses. My favorite sugars are silans. Together with other enzymes, we can degrade them into smaller molecules that provide energy for these green fellas over here, called bacteria.
Wow! That's why the lake doesn't overflow with leaves. I want to understand you better. So I will take a sample and bring it to my lab.
Do you know that there are also other kinds of enzymes? They have different modes of action. Do you remember the drink you had before? Branching enzymes make the slowly digestible starch for that drink. They like cornstarch and can modify its structure.
Oh, let's take another sample. Let's see what happens if I mix each enzyme with its favorite carbohydrate and incubate them. Various analytical techniques help me understand what the enzymes do with their substrates. I perform different analyses to obtain a set of results. This blue enzyme is called a branching enzyme. It can act on glycogen or starch from corn, for example. The enzyme first cleaves a part of the linear chain and then reattaches it at a different position, thereby making an extra branch. That's why it's called a branching enzyme. It explains why it's used for the slowly digestible starch drink. The structure becomes more complex. Finally, I have characterized the enzyme and I understand how it works. But where do they come from and how can we get more? I still have bacteria from the lake. Let's put them in a flask and add sugar and recreate the conditions of the lake. Let's see what happened. The bacteria multiplied.
We produce enzymes and have their construction plans encoded in genetic clusters called polysaccharide utilization loci. We release some enzymes into the liquid. There, they degrade sugars and provide energy.
Oh, so there are more enzymes to discover, with more interesting applications for the production of biofuels, pharmaceuticals, slowly digestible starch, and fermentable sugars. This was an interesting day, wasn't it? Now you have a clear idea of what the Bioproduct Engineering Research Group works on: heterologous enzyme production, novel enzyme discovery, and carbohydrate characterization and modification.